Hi friends, today we are going to see very important question. Look here. That is the question. Let the period of revolution of planet at the distance r from the star be t. Means t be the period of revolution, r be the distance of the planet from the star. Prove that it was the it prove that it was at a distance of 2r from the star. Its period of revolution will be the root 8t. Means if the distance becomes double, then we have to prove that period of revolution will be the root 8t. Understand that question? Look here. Kepler's law, third law. What is that Kepler's law? The square of the period of revolution around the sun is directly proportional to the cube of the mean of the distance of the planet from the sun. Means period square of period means t square is directly proportional to the r cube. That r means the mean distance of the planet from the sun. That is the t square directly proportional to the r cube. T square equal to kr cube. K is constant. If a distance of the planet is 2r, means here in the place of r we have to put 2r. The period of revolution we have to take that t1 for a change. That t1 square equal to, that put here 2r k 2r bracket cube. Therefore t1 square equal to k 2 cube is 8 k r cube. That is division. Equation 1 and 2. Equation 1 divide equation 2, we get t square by t1 square equal to, that is equation 1, kr cube divided by 8 kr cube. K get cancel, r cube get cancel. Here remain t square divided by t1 square equal to 1 by 8. Therefore by then taking the square root, t divided by t1 equal to 1 upon root 8, and take cross multiplication, you get t1 equal to root 8t. It is very important, you have to prepare this. Then we have to see another point, another example. That is the example. Look here, examples on that. Gravitation. First example is that an object takes 5 seconds to reach the ground from a height of a 5 meter on a planet. What is the value of g on the planet? Means an object takes 5 seconds to reach on the ground from the 5 meter height. What is the value of g on the planet? You have given that t equal to, time means 5 seconds, height h equal to 5 meter, and u equal to 0 meter. That is the initial velocity. U equal to 0 meter per second. Therefore g, you have to find g. Formula is s equal to ut plus 1 half at square. S means height 5, u 0 into 5 plus half. A means g, g means gravity, and t means 5 square. That 2, it will become 0. That 2 come here, that is 5 into 10, and 25 into g, and that is 25 divides. Therefore 10 by 25, you will get g equal to 0.4 meter per second square. That is the gravity on that planet. Second example is like that. An object thrown vertically upward reaches at height 500 meter. If we throw an object upward direction, then it will reaches 5 meter. What was the initial velocity to reach the 500 meter? What is the initial velocity? How long will the object take come to back to the earth? And that what is the time taken by the object to come or reach on the earth? G equal to 10 meter per second square is given. Given is h means height, means s equal to 500 meter, g 9.8, but for the convenience it is given 10 meter per second square. To find u equal to question mark and t equal to question mark. Formula is, that is the third formula, v square equal to u square plus twice a s. But if v equal to 0 and a equal to minus g, because at the time of the going away from the earth minus g with negative sign taken minus 10 meter per second square. 0, put here 0 u square plus 2 into minus 10 into 500. Yes means h. That is the multiplication. 500 into 10, 5000. 5000 into 2, 10,000. And minus 10,000 comes here, plus 10,000. U square equal to 10,000. Take square root. Taking the square root, that is the u equal to 100 meter per second. Means that is initial velocity. When you throw that stone or the object, it will, that is initial velocity will be the 100 meter per second. But when that stone come down, at that time its velocity, initial velocity becomes 0. Therefore u equal to 0 and a equal to plus g. That is the, yes, you have to change the formula. S equal to ut plus 1 half at square. That s means height 500, 0 into t plus half into 10 into t square. That is 0, it will become 0. That 2 comes here. That, or here you have to divide. 2 into 2 ones are 2, 2 5s are 10. Means that here remain only 5. Take 5 as a divide. 500 divided by 5 equal to t square. Therefore t square equal to 100. Therefore t equal to 10. Means that stone or that object takes 10 seconds to go up and 10 seconds to come down. You have to study earlier in the previous lecture. That is the going up and coming down. It takes the equal time. The initial velocity, that is the 100 meter per second. Time taken to the reach to on the earth, that is the 2 into 10. For going up 10 seconds, for coming down 10 seconds, 2 into 10, 20 seconds. It is that example. Third example, that a wall falls off a table and reaches on the ground in 1 second. Assuming that g equal to 10 meter per second, calculate its speed. Its speed on reaching the ground and the height of the table. Means that is the height of table. You have to find the height of table and you have to find the what is the speed of that ball at the time of the reaching on the ground. Given u equal to 0 at the first initial velocity 0, g equal to 10 meter per second. Yes, you have to find h or s, and v you have to find. Formula is like that. That is the s equal to ut plus 1 half gt square. S equal to u is a 0, half into g is a 10, t is 1, 1 square is 1, 2 divide 2 by 2 to 10, 2 ones are 2 5s are. Here only remain 5. Therefore s equal to 5 means that height of a table. Height of a table must be the 5 meter. Then phi square equal to u square plus twice gs. Phi square equal to final velocity you have to find. U is 0, 2, g is 10, s is 5, means 2 into 10, 20 into 5, 100. That is the phi square equal to 100. Therefore phi equal to 10 meter per second. It is the velocity of that ball at the time of reaching on the ground. Then next example you have to see, that is the mass of the earth. The mass of the earth. The mass of the earth and the moon are 6 into 10 raised to 24 kg and 7.4 into 10 raised to 22 kg respectively. The distance between them is 3.84 into 10 raised to 8 kilometer. Calculate the gravitational force of attraction between two. Means you have to find the force of attraction between moon and earth. That is the mass of earth is m1, 6 into 10 raised to 24. Mass of moon m2 equal to 7.4 into 10 raised to 22. That is r equal to 3.84 into 10 raised to 8, and g equal to, that is 6.67 into 10 raised to minus 11. Formula f equal to g m1 m2 r square. Put the values here. 6.67 into 6 into 7.4, its multiplication is 297. That is 797, I think that is here 797 into 10 raised to 35, and here that is square of 3 point square of 3.84 3.84 into 10 raised to 8, it will 14.7456 10 raised to 16. Here 3516, from the 3516 get cancelled, it will get its division also will get 20.1 into 10 raised to 19. Therefore, if it can write it as 19 to 20, then you have to transfer that decimal point to here at 2.01 means 2 into 10 raised to 20 Newton. It is that example. And last example of this chapter, that is the mass of the earth 6 into 10 raised to 24. The distance between the earth and the sun is 1.5 10 raised to 11 meter. Of the gravitational force between, find the gravitational force between the two, 3.5 into 10 raised to 22 Newton. What is the mass of sun? Means that is you have to given the mass of the earth, distance between two given, and force is given also. Then you have to find the mass of the sun. The mass of the earth m1 is given, distance between them r is given also here, force is also given here, and g, value of g is also given. Therefore, you have to find the mass of the sun m2. Formula F equal to g m1 m2 divided by r square equal to 6.7. These values put here. That is 3.5 into 10 raised to 22. 6.7 into 6, we get 40.2. That is 24 minus 9 11, that is 13 into m2. Its square 2.25. Its square 10 raised to 22. 3.5 10 raised to 22 equal to 40.2 into m2, that is divided by 2.25 into 10 raised to 9, because that is 13 get cancelled, only 10 raised to 9. Transfer those denominator here, 3.5 into 2.25 into 10 raised to 9 and 10 raised to 9 and 10 raised to 22 divided by 40.20. Here 2 point, here 2 point, that is cancel the, and you will get 787.5 into 10 raised to 31 divided by 40.20 equal to m2. If you divide this, that is the 1.96 into 10 raised to 30 or 19.6 into 10 raised to 31. You have to write. That is the m1. It is the mass of the sun. If you like those all examples, you understand this, like it, subscribe our channel and send to your friends. Take care, stay home, stay healthy and busy in study. Thank you.